All right, so good morning, everyone, and wishing you all a happy new year. And let's get started with our discussion on big data. My name is Suraj, and I'm basically instructor at 𝗚𝗏𝗴𝗶. It's my own company and startup, right? And I've been doing a lot of work in big data. I have around 10 years of experience in the IT, and I'm currently working with Apple Hyderabad, right? Like I'm doing a consulting there, and I've been working on this big data since last 8 years, and I have seen a lot of startups using big data, a lot of middle level companies using big data, a lot of product based companies using big data. Right? I started this program. I started this platform 𝗚𝗏𝗴𝗶 to help many people get started with a fundamental course on big data. Right? So we provide a free course. We provide a paid course. Both of them has their own advantage, right? Like free course, we have a fundamental course on big data for 45 to 50 hours, right? And the whole paid course is around 10 months long, right? So because I personally believe that whatever I have learned in this 8 years of my big data experience, it's not possible for me to wrap it up in just 30 hours of course or 2 months of course. Big data is really big. Okay, so let's understand what exactly is big data, right? And what kind of companies are basically looking for, big data engineers, and what is the, what is the day-to-day activity you basically do as a data engineer. Okay, so I would focus on one thing, that is data engineering. I will focus on one thing, that is data engineering, and let me tell you that data engineering is not equal to big data. You have to be very clear, and let me tell you what exactly I'm talking about. Okay, so mostly when you say I want to do a big data course, right? So you end up learning Hadoop, Hive, Scoop, components, right? Scala, Spark, done, right? So you would basically end up learning these components, and when you go to the real-time company to implement something, right, it's very hard for you to do this integration altogether, because it's not like you are just going to work on only these components, right? So what I've done is I've curated my course as a data engineering course, and I've divided them into two parts. I call it data engineering 1 and I call it data engineering 2. Okay, now data engineering 1 contains a core Java, which is very important. Many folks don't understand the importance of core Java unless until they go to the interview and they realize that, hey, people are also looking for people who are good at Java programming, right? So core Java, you need a Hadoop MapReduce framework, right? And then you need components like Hive, Scoop, HBase, or maybe Cassandra, right? And then you will also have to learn a lot of like real-time tools like Maven, JUnits, Log4j, okay, maybe 𝗂𝗘𝗘𝗀, Java code coverage, okay, and Sonar reporting, and many more. Okay, so basically, if you see, these are really not a part of your big data. These are really not a part of your big data. Any training center will not basically focus on teaching you this, right? But if you talk about the data engineering, yes, it has to be a part of the data engineering, because when you call yourself a data engineer and when you join a company, working for a big data projects, so people would expect you that you have a knowledge on these tools also, because this is what you'll be using daily daily in and out. Okay, so when you are preparing for yourself, when you're preparing on your own, make sure that you learn all these things very in detailed manner. Okay, so this is what I basically offer as part of my data engineering 1 course. And data engineering 2 course, what we focus only on Scala, Spark, Kafka, Elasticsearch. Okay, so we focus only on these 4 components as part of our advanced big data course or data engineering 2 course. And this course almost is around 100 plus hours, 115 plus hours. And this course altogether goes for another 115 plus hours. right? So you can understand how exclusive the course is, and this is how the course has to be, okay? Because like you cannot trust people when they say the data engineering can be completed in just 30 hours, right? I know, like there's so many training centers who will offer you a course on big data for 30 hours, and let me tell you, be very honestly, that it needs at least 2 months only to learn programming language. If you are not from programming background, it's not it. Any language you want to learn, maybe you want to learn Python or maybe Java or maybe Scala, it needs at least 2 months to learn only the programming language. How can a data engineering course be over in just 30 days, right? Or 30 hours? Okay. Now, when you are preparing yourself as a data engineer for the data engineering role, I would suggest you that you must learn all these things. Okay, whether you learn it from me or whether you learn it on your own, that is completely up to you. But this is what I have divided this course into two parts: data engineering 1 and data engineering 2. But as a data engineer, you must have knowledge on all these things, right? If you are trying to put some experience or if you are trying to work on a good organization. Okay, now let us understand, like what is basically your role as a data engineer, right? So see, in any company, wherever you join, right, the role of a data engineer or a role of a Java developer would be mostly same, right? Like we get a requirement from a company, we get a requirement from client, and based on the requirement, we'll have to design the solution based on all the tools, whatever I've mentioned here, right? But let me tell you, these are not the exclusive tool. There are so many other tools as well. For example, some company may say, hey, we would be using Flink, right? Somebody may say, hey, that's okay, but I also want to use a traditional MongoDB, right? So the list can go on, and there are so many tools which can be used together. But what I feel is, if you want to put your resume, if you want to create your resume in a better way, then I would suggest that you should have at least these skills on your resume. Okay, now you may ask me, hey, why are we again focusing on MapReduce? I'll tell you one thing, that MapReduce is the heart of the data engineering, and if you don't understand MapReduce, you'll not be able to do a very good on the problem solvings in the distributed way. And this MapReduce will basically teach you a lot of problem solving stuff, and you will be able to become more better in writing a distributed code. Okay, you may skip it, but let me tell you, if you're working on Scala one or other day, if you're working on exclusive projects one or other day, you will realize sooner or later that Spark is internally somehow using MapReduce frameworks and the MapReduce libraries. Okay, they are internally using. I'm not saying that Spark job is converted into MapReduce, but what I'm saying is, if you see the Spark code, then you'll find that Spark also uses the concepts of MapReduce in few cases, and it's very important for you to learn this as well. Okay, now if you have joined me today for the first time and you have no clue about what a big data is, right? So let's talk about what is a big data. So big data, I'll just erase this board. Okay, now at a very high level, big data is basically a problem. Okay, so if somebody asks you what is a big data, your answer should be big data is a problem. Okay, and let me tell you, like, big data is basically a problem to solve. Okay, and the problem is data is huge. Just a minute, guys. Okay, so big data is basically a problem when the data is very huge or it is taking a lot of time to process. Okay, so I would basically classify any data as a big data problem if it meets at least these two requirements, if it meets at least these 2 points. Okay, now the first point is the data is very huge, and how much huge, that depends on the system. Okay, for example, if I say I have 100 GB of data, if I say I have 100 GB of data, now this 100 GB of data you can easily store in a hard disk of 1 TB, is not it? You can easily manage to store it in a hard disk of 1 TB. And if you see this, then you will say, hey, volume wise, I'm okay, right? Because I have 1 TB of hard disk and I can easily store this data in my 1 TB of hard disk, right? So in this case, you may not call it a big data, right? In this case, you may not call 100 GB of data as a big data. But now the next point, let's consider this next point, okay? How much time will it really take to process this 100 GB of data, okay? So let's say it takes at least 10 hours. Okay, let's say it takes at least 10 hours. Now you have to go and check with your organization, hey, I need at least 10 hours to process this 100 GB of data, and is that acceptable to you, right? And if the company says that's okay, then you really don't need to call it a big data. It is a traditional problem. Okay, if they're okay to have your 100 GB of data be processed in 10 hours, then you will really not call it a big data. Okay, it will still be a traditional problem for you. Okay, however, the organization says no, 10 hours is quite long, and we want to process this data at least by next 1 hour max, right? Because a lot of customers or a lot of people are waiting for this result, and we cannot really delay this by 10 hours every time we run the program. Then you have a problem. You have a big problem. What? The processing time is not acceptable, right? So whatever processing time it is taking, whatever code you have written, it is not acceptable by the organization. Now you will say, okay, then I will call it a big data, and we will have to solve it using a distributed way, right? So big data will basically solve the problem in a distributed way. Okay, so let me tell you, all the classes, whatever I conduct, basically I conduct it in this fashion, right? So no more screen sharing, no more boring PPTs. It will be all live interactive like this. Okay, right. So we are basically are trying to understand that the big data is basically a problem when you have either a huge volume of data or if the processing time is very high, right? Now, if you want to solve this problem, there is only one way: distribute the data into multiple parts so that it can be solved very, very quickly. Is not it? So in the distributed way, what we do is we have a lot of computers connected together, right? We have a lot of computers connected together, and each of these computers would have the software installed. And what is that? That is a big data software. Okay, it could be Hadoop, it could be Spark, it could be anything, right? So we will have a big data software installed in every place. Okay, and now this data, 100 GB of data, would be broken down into pieces, right? And maybe equally, let's say, so if I say equally, then let's say 25 gigs here, 25 gigs here, 25 gigs here, and 25 gigs here, right? So it is now 100 gigs of data. And now we will start processing the data, right? And now if I process the data, then maybe, it may take, see, one system was taking at least 10 hours, right? And if I divide it by 4, so let's say more or less it is, taking 2.5 hours. So now it will take 2.5 hours, right? It will take 2.5 hours. All these machines will work together and combinedly finish the work in just 2.5 hours. And you go to the management and you say, hey, I've done some big data now. Now I'm able to process the same data in just 2.5 hours. Are you okay with that, right? And the manager may still say, no, I'm not okay with that, right? So what you may say, okay, I will increase this more, right? So I'm adding it. I have added now 1, 2, 3, 4, 5, 6, 7, 8, and say 10. Let's say we have added it, 10 machines all together. So if I add 10 machines together, now what will happen? This 10 hours of job will be exactly divided by 10. And now I'll be able to complete it in 1 hour, right? And you may go to your boss and say, hey boss, I'm now able to completely, complete the job in 1 hour, which was earlier taking 10 hours. Is that okay? Now the boss may say, that's really great, but can you make it to 30 minutes now, right? And it is again not possible because you have a limitations, right? So if you want to make it into 30 minutes, then you may have to add more and more nodes. The more node you add, the time it will take to process the data will be equally less. Is not it? Okay. Now let's try to understand what is this big data in Hadoop. This is a common confusion where people basically come across this word, big data in Hadoop. And even when I started learning big data, in 2012, I was confused. What is this big data and what is Hadoop? And it was really difficult for me to understand. So let me explain you what exactly is the difference between these two. And let me tell you, they are really not same. Okay, they are really not same. So let's understand, let's discuss that, and you'll understand how exactly they are really not same. So we are going to talk about big data and Hadoop, right? And what I'm saying is big data is not equal to Hadoop. Okay, let's understand that. Okay. Now, for example, if I ask you, can you tell me some of the programming languages that you know, right? All of you will say, hey, I know C, I know C++, I know Java, I know Scala, I know Python, right? If I ask you, can you tell me some of the database software you have ever used? Then you may say, I've used MySQL, I've used DB2 from IBM, I've used Postgres, and so on, right? Now, if I ask you, can you tell me some of the web UI or framework you have ever used, right? Now you may say, I've used PHP, okay, I have used like Angular, right? React.js, and so on, JSP, and so on, right? Now, similarly, if you look into this now, right? If you look into this, what I can understand from this is C, C++, Java, Scala, Python. They are actually languages, right? So they are basically physical entity which you can at least sense, right? Like you install Java in your machine and you write some code, and that code you can see, okay, this is written in Java. So these are some physical entity which you can at least feel, is not it? And this programming language is just a category. This is just a category. Have you ever written a prime number? Have you ever written a program to print whether a number is prime or not in programming language? No, you have not done it anytime, right? If I ask you to write a program to print whether a number is prime or not, you either use C or C++ or Java or Scala or Python, but you don't do it in programming language. So what I'm trying to tell you is this is just a generic term, right? This is just a generic term, and these are the real implementations, right? These are the real implementations. So similarly, if I talk about database, these are the real implementations. Have you ever created a table called employee in a database? No, right? You either create it in MySQL or maybe DB2 or maybe Postgres or maybe some XYZ database implementations, right? So these are implementations, the real implementations, and this is just a category. That's not it. Similarly, likewise, likewise, if I talk about big data will come here, right? As I have told you, big data is basically a term given to a problem. And what is that problem? Either the data is used or the processing time is or the processing time is really very high. Okay. So big data will come here. It is a category, and Hadoop is one implementation of it. Okay. Hadoop is one implementation of it. Your Spark is another implementation of it. Disco is another implementation of it. Hydra is another implementation of it. CPCC is another implementation of it, and so on. Okay. Now you may say, hey, do I need to learn all of this? No, even I don't know how exactly it works, right? I just know them by name, but not, I have never worked on such implementations. Okay. So big data is basically a generic term, a category, whereas Hadoop, Spark, Disco, and all, they are the real implementation which you can use, right? Now, what made Hadoop and Spark so popular? First, let's talk about Hadoop. What made Hadoop so popular? The only one reason was open source. Okay, so the most important reason was open source. Since it was open source, the source codes are available to all the folks, and many people can download and do some, R&D and development on the core product. And then if they feel that there are certain improvisations they can do, they can start improvising it, right? And this is one of the reasons. Okay. Now let me tell you guys, this Hadoop is entirely written in Java. Okay. So they're primarily developed in Java programming language, right? And that is the reason I say, if you want to be a serious data engineer, not the one who writes only SQL query at company, if you want to be a serious big data engineer, right, then you should focus on learning Java. It's not difficult at all. It depends on who is teaching you and how are you learning. These are the only two factors that can make you a champion, right? Number one, who is teaching you, right? How is he teaching you? And number two is, how are you learning? If they are balanced, then you will be able to learn Java programming very, very easily. Okay. Now, so big data was started, and then it slowly gained a lot of popularity, right? And because of that popularity, right, they were also made available in some other languages like Python. Okay, but I'll tell you one thing, that see, the support or the integration, right, the speed which comes on your Java kind of which comes with Java Hadoop, you will not be able to get them from Python Hadoop. Okay, of course Python also supports like writing a MapReduce job and all, but I would say, still people prefer using Java if somebody wants to write a MapReduce program. Okay, because this is entirely written in Java, and then there would be always a tightly coupled, or the integration would be quite smooth than doing it with the third party language. Okay, so they have also supported Java, they've also supported Python, just because they wanted to widespread it to many programming languages. Is not it? Okay, now let's talk about this Hadoop. What exactly is Hadoop? How exactly it started? Who started this? When it came to the market? And how does it really work? So let me erase the board. Okay, now let's move on, and we will talk about Hadoop. Right? So Hadoop is basically a framework written in Java. Right? A big data framework written in Java. It is basically a distributed technology, right, to process big data. And it was, I think, officially launched in 2006. Okay, search the internet for the exact date. And it was basically designed by two scientists, 𝗥𝗘𝗘𝗃 and 𝗥𝗃𝗃𝗃. Okay, check the spelling in the internet. So it was introduced in 2006 by the two scientists, 𝗥𝗘𝗃 and 𝗏𝗃𝗃. Okay, and these guys, I believe, were working with Yahoo, I believe, and wherein they were actually, like writing some implementation. So they were basically trying to write some implementation to process a huge volume of data. The problem, what these guys were facing, were the data was very huge. I think it was not 2003, it was 2000, sorry, it was 2003, not 6, but check the date in the internet, guys. Okay, so now these guys were, working on a project which was all about collecting the data from internet and doing some processing on that data. Okay, now that time the hardwares were not so powerful. Okay, so I'll tell you, like I bought my first laptop when I was in BTech second year in 2007, right? And that time the highest configuration what was available was 80 GB of hard disk, right? And 512 MB of RAM, right? And it was, I think, dual core. Okay, this is what the configuration was available to the common people, the highest configuration possible. Okay, like for a general purpose, laptop. Now I got another laptop. I bought another laptop in 2000, maybe 15. Yeah, and I got 1 TB hard disk. Okay, and 16 gigs of RAM. Okay, and 8 cores i7 processor, right? So this is the specification of what I got in 2015, and that time this was the latest available configuration for the general public. Okay, I got my next laptop in 2020, recently December. I got a MacBook which has 2 TB of SSD, okay, 64 gigs of RAM, and 8 cores i9 processor. right? Now, why am I telling you this story? The only idea is I wanted to tell you how the hardwares were improved over the period of time, right? Earlier, when I used to have only 80 GB of hard disk, slow hard disk, now I have got 2 TB of SSD, right? Earlier, when see, if you see this, now I can say more or less my hard disk that time and my RAM this time is more or less equal, right? Somewhere equal. Now you can understand what kind of evaluation has been done on the hardware over the period of time, right? So what kind of evaluation has been done on the hardware over the period of time, right? So those days were very painful for these guys, because no doubt they don't use our the traditional system whatever we do, right? But even though I can tell you that they were really not so much powerful than what we have today, right? That's for sure. So these guys were actually working on such project which demanded them to collect the data and like process the data, and they had some tiny server which I really don't have any clue what was the actual configuration. Okay, but they were always facing the problem every day. So every time when they were running out of hard disk, or maybe running out of memory, or whenever running out of the processor, they were trying to scale it up. They were trying to add more power to it, right? For example, if I assume they had a 500 GB hard disk, for example, then they started adding, let's say, 200 GB more, and then again 200 GB more, again 200 GB more on the same system. They started upgrading the same system, but you cannot upgrade the same system to any limitations, right? To any capabilities, because all the hardware will definitely have a limitations. It's not it. Like 100 people, the power whatever you can get from 100 people, you cannot get that from a single guy, no matter how like good you feed him, right? He can never become like a powerful guy like 100 people altogether. Okay, so they were trying to add a lot of components every time they were hitting the bottleneck. They were reaching the threshold, and this is basically called as vertical scaling. Okay, this is basically called as vertical scaling, like this. The way we grow, when we were a child, we were quite small, and then we started growing in this direction, right? So this is basically called as a vertical scaling. Okay, now that was the problem, right? So they were trying their level best to scale it up as much as they could, but they could not really do that, because at the end of the day, the hardware will have their own limitations. It's not right. Now during this time, it was the really painful days for those guys, and at the same time, there were scientists from Google. There were a couple of scientists from Google. These are the people who actually does PhD from reputed organizations, right? So the scientists at Google, what they did, they published 2 papers. Okay, and those two papers were MapReduce and GFS. Okay, and when I say paper, that was a theoretical concept, right? So for example, if I ask you how can you prepare a tea, right? So you will give me your own answer, like I'll boil some milk, and then put some tea powder, and then put some sugar to taste, whatever it is, and put something else, whatever you want. If you want to have tandoori tea or whatever it is, and then you will give me some recipe, right? So when you give me a recipe, that does not mean that you have really given me a tea, right? You have just given me a recipe. But at the end of the day, it is me who have to cook it as per the recipe, right? Similarly, when we say they have published the paper, they're just given a theoretical idea of how can we basically solve a big data problem, whatever we face, okay? And these two papers were exactly the same thing what these guys were actually looking for. Okay, and they were really happy that, okay, we have got some idea, and I think we can exactly try to build something by implementing this kind of these 2 papers. Okay, so these folks, 𝗥𝗘𝗘 and 𝗙𝗪𝗏, started implementing this paper. They started cooking their food as per this recipe, right? And that final food became Hadoop. Okay, now in Hadoop, MapReduce is kept as it is, MapReduce, the name is as it is, the name is not changed. But GFS, they cannot use this Google name, so they said GFS would be renamed to HDFS. Okay, so Hadoop distributed file system, and that is how Hadoop was born. And if I believe the story, if you believe the story, then as per the story, it says that dog cutting son had a small toy, yellow toy elephant, and the kids are very experts in coming up with unique names, right? So he was like Hadoop Hadoop, so he was just murmuring around Hadoop 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 to his toy, and that's how the name was given to this particular project, saying that okay, the name looks short, right, and the name looks unique, it will not have a copyrights issue anytime. So that's how they gave the name Hadoop to the product whatever they built, and that's how the Hadoop was born, right? And people have started implementing this Hadoop. I know a couple of folks who have started implementing Hadoop since 2010, right? I started learning and implementing that since 2012. And that's how my journey is in 2020. Okay. Now you may ask me, hey, you have around 8 years of experience in big data. Do you think the market will be better tomorrow? The market is still better today, right? And I really don't care about the future a lot, right? I basically care about my present. If my present is good, I know that my future will also be good. That's not it. So see, things will come, things will go. Today, like people may not prefer using MapReduce. People are preferring using Spark, right? I don't know what will happen after 2 years. Maybe people may go out of Spark. Maybe something more powerful, tool may come, and then people might get migrated to that powerful tool. That's not it. So that's how the evaluation is, and then it's important to learn everything step by step, right? For example, I would say all you need is a good marks in 10th and 12th, right? Then why did not you learn directly, maybe 8 9 10 and then 11 12? Why did you waste a lot of time learning those Johnny Johnny yes papa, which is not even asked in the syllabus, right? Because these are, trust me, all these were the building blocks, and somehow they make you smart over the period of time. So you will have to plan your journey accordingly so that you can exist for a long time, right? So that's how it is. Now let's move on and let's talk more about this MapReduce and GFS. I'll take a 2 minutes of break and let me check if anybody has any questions. So I'll go back to my system. Guys, anybody has any questions for me? And the questions should be till whatever we have discussed. Let's talk with the context of the discussion. Okay, I'll take up more questions at the end of the session. All right, let's move on. Okay, now let's talk about Hadoop, right? So we understood how Hadoop came into the market, right? Now, as I've told you, Hadoop has primarily two components. One is your MapReduce, and the next thing is your HDFS. Okay, many people call it SDFC. I don't understand the reason, but don't call it SDFC. It is not a bank. It is SDFS, Hadoop Distributed File System. Okay, all right. Now let me tell you what exactly they are. Okay, so SDFS stands for Hadoop Distributed File System, and it is basically to store data. Okay, and this MapReduce is basically to process the data. Okay, so MapReduce is basically to process the data, and SDFS is basically to store the data. Let's understand how exactly this data is basically stored. Okay, so see, whenever I say that I have implemented a Hadoop, we have a Hadoop cluster in our company, then you will basically have a lot of Hadoop cluster like this, a cluster with a lot of nodes. Okay, so each of these machines are called as node. Okay, and what is a node? I'll say node is an independent system. Node is an independent system which has its own CPU, which has its own storage, which has its own memory. Okay, typically any node is basically a machine which will have its own CPU, storage, and memory. They are called as a node, right? So if I look into this example, I have 1, 2, 3, 4, 5, 6. So I'll say this is a 6-node cluster. These are 6-node cluster, and all of these machines are basically connected together by a network, right? And let me assume that this machine configuration is 2 TB of hard disk, okay, and let's say 8-core machine, okay, and let's say 32 gigs of RAM. Okay, let's assume this is basically a configuration of one such machine. Okay, and if I assume that I have a 6-node cluster, let me make it 10 because I want to quickly calculate that. Let's say these are all 10-node clusters. So if I have a 10-node cluster, then what would be the total size of the hard disk available? It would be 20 TB, right? How many cores is available to you for processing? 80 cores, right? And what is the total memory you have? 320 GB. Okay, so this is what I'll call the configuration of your cluster. Your cluster has a capability to store 20 TB of hard disk, 20 TB of data, and 80 cores are available for processing, and then 320 GB of RAM to load the data into the memory, right? Okay, now how this HDFS basically stores the data, let's understand this. Okay, so suppose you have a file of 200 MB. Okay, let's say you have a file of 200 MB, right? And you want to store this data in your cluster. So if you want to store this data in your cluster, you could have easily copied this data and stored it here directly, because the size is 2 TB and you can easily store 200 MB, right? Anyways, it's not it. But that is not how HDFS stores the data. HDFS will break the data into pieces, and those pieces are called as a block. Okay, so by default, when you are working on Hadoop, you have Hadoop 1 version, 2 version, and 3 version. Okay, now this is currently working. This is currently what used in the industry. This will start coming after a few years. This is completely outdated. Nobody uses it. The moment you say I'm using Hadoop 1 in your resume, you are thrown out of the interview for sure. Okay, so Hadoop 2 is what people are using these days, and in Hadoop 2 the block size is 128 MB. Okay, that means any file you give, that will be broken down into multiple pieces, and each piece can be of maximum 128 MB. Okay, understand this point. This is very, very important. So 128 MB is basically a block size, which means if I have a file of 200 MB, then this will be broken down into 2 pieces. I'll say B1, okay, will be of 128 MB, and B2 would be of 200 minus 128. How much it is? 72. Right? So this file will be broken down into 2 pieces, B1 and B2, and B1 is of 128 MB, which means in Hadoop, right, by default, if you are not changing it, it is configurable, purely configurable. But if you stick to the default, then by default, the file will be broken down into pieces, and each piece can be of maximum 128 MB. Okay, so this B1 will be stored somewhere here, maybe, okay, or anywhere. And this B2 would be stored somewhere here, maybe, and or possibly anywhere. So this is how the data would be broken into pieces. Okay, this is how the data would be broken into pieces, and they would be stored in various machines, right? In various nodes of the cluster. Okay. Now the problem is we have stored the data in a distributed way, right? But the biggest problem what you would face is what if this node goes down for any reason? It is possible that the node, whatever you have been configured, they may go out of service for various reasons, maybe for the network issues or the hard disk got corrupted or whatever it is, right? So it is highly possible that the machine may go out of the service. Okay. Now, if this machine goes out of the service, then definitely you will have to lose this data B2. It's not it. But Hadoop says, no, we will not let that happen. How? They will start replicating this data into other machines, which means the data would be duplicated. The same data would be duplicated into other system. Okay. And so that the duplicate data can be maintained. So you have a B1 here. So you will also have B1 replicated here. You'll also have this same B1 replicated here. Okay. So you have B2 here. You may have B2 replicated here. You may have B2 replicated here. Right. And that's how the data would be replicated. So this is your primary copy, right? And these are your replicated copies. It's not it. So the data would be replicated across the node. Now it really does not matter even if your B2 is, even if this node is particularly out of service, because you already have the data copied somewhere else. Okay. Now you may ask me, that's really fine, but don't you think that you are wasting a lot of space? Because earlier if you have a file of 200 MB, then you will basically be wasting 600 MB to store this 200 MB of data, because you are duplicating it 3 times altogether, right? I totally agree with you, but the thing is, I really don't care about the storage. Storage is cheap than the data. I cannot really lose the data at any cost. And that is how your whole entire cloud works. Okay, the moment you store the data in any of your cloud, those data are actually replicated. You use Dropbox, you use AWS, you use any third-party cloud services. The data are replicated and they are stored in many machines so that you don't lose the data at any cost. I've been using Dropbox since last 5-7 years. The paid version of Dropbox. In fact, I'll say my whole 2 TB of hard disk on my Mac is completely in the Dropbox, so that even if my machine goes, out of service, I should not lose the data, right? But what they do is they basically replicate this data and they store it in various data centers. Is not it? All right. So that's how the data would be broken down into pieces and they are replicated so that you don't lose the data. Okay, done. Now, this is how the data would basically be stored in your HDFS, broken down into pieces, and each piece can be of maximum 128 MB, the block size. Okay. Now, suppose if I have a folder called data. And let's say this data folder contains a lot of files. Okay. Let's say file1.txt, file 100.txt. Okay. Now each file is of 1 KB. Let's assume each file is of 1 KB or few KBs or maybe 1 MB also. Okay. Now if I have 100 files in this data folder, can you tell me how many blocks this will be converted into? See, if I assume the file size is of 1 KB, then altogether the total file size would be 100 KB, is not it? The total file size will be of 100 KB. And you may say, okay, 100 KB is less than 128 MB and it would be stored in a single block, but that does not happen, right? So see, the rule is very simple. The rule is at least 1 block for 1 file. Okay. And if the file size is more than 128 MB, then multiple blocks. Okay. So by going by that theory, then what will happen is for this file1.txt, 1 block will be created. For file2.txt, 1 more block will be created. For file3.txt, 1 more block will be created. Each of the block size 128 MB. But that does not mean that the remaining, whatever unwanted space, whatever, space was not used will be wasted. That will never happen. Okay. So if I store this data, 1 KB of data into my HDFS, what will happen is if I say this is the block of 128 MB, right? Then only 1 KB would be used. A small portion of it, only 1 KB would be used, and the remaining all would be set free. Okay, so that can be used by somebody else. But it is really not a good idea to store 1 KB of data. It is not really a good idea to store large number of small files. Okay, because it impacts it impacts your name node. And what is this name node? Name nodes are basically services. Okay, so whenever you say you have installed Hadoop on your machine, then there are certain components, there are certain there are certain processes that has to be up and running, and one such process is name node, which basically does a housekeeping of all the files. It has all the information of what are the files you have stored, where exactly those files are stored, how many blocks they are divided into, what is the replication factor, and so on. So the more file you add, it will be difficult for the name node to maintain such details, right? So I will never recommend you to work with smaller large number of small files. Always work with small number of large files. It's okay to have 2 files of 100 MB each, but it is not okay to have 1000 files of 1 KB each. Okay. All right. So now we've understood how this, like data are basically stored. The data are stored in a distributed way, and they're stored across the machines. Is not it? Now let's understand how does this MapReduce work on this particular data. Okay. So at a very high level, you will use Java API. You will use Java API to write your MapReduce program. Okay, you wrote the MapReduce program. This program would be later converted into a jar file, packaged into a jar file. Done. Now this jar file is what you will submit to your cluster by using a command called Hadoop jar. Okay, so when you submit this jar, while you submit this jar, you'll have to say, hey, I have written a code to process a data, and the data name is, let's say, file1.txt. Where is that? Here it is. Okay, so let's assume this was a file1.txt of 200 MB, right? So you will say, hey, I have written a program to process this file1.txt, which is of 200 MB, and I would like to process this data. The moment you give this information to Hadoop, Hadoop understands that file1.txt means this particular file, which was broken down into B1 and B2, right? And this B1 and B2 are stored across in the whole cluster, right? So Hadoop is smart enough to say, okay, I will process B1 here, and I will process B2 maybe here, based on the resources available. Okay, so Hadoop will process this data like this, right? So B1 will be processed here, B2 will be processed here, and later this two data would be, the result of this data would be collected together, and you get the final output, which means the processing is happening in a distributed manner as much as possible, right? So the data would be processed in a distributed manner, the results will be collected together and will be given it to you as an output, right? So that's how basically your MapReduce code will be actually processing the data. Now, one thing I want you to note from here is, in this case, the data will not travel. The data will sit on its place. That's the beauty of Hadoop. Okay. So Hadoop says, see, whenever you work on the traditional, traditional web application, what do? You open a web page, you enter your details, hit enter button, your data will travel to the server wherever the code is deployed. The code will run on your data, but the data is traveling. The code remains as it is wherever it is deployed, right? Exactly. Your data is traveling and you are processing the data. This is what happens in the internet world, right? For example, maybe let's say I have a photo and I want to remove the background from the photos, right? So there are so many online websites. What you need to do is you need to upload your photo, right? And you'll say remove background and remove background by this much quality, and you say submit. What happens is your photo would be uploaded to the server. Is not it? And in the server, one or other guy has written some program, and that program will be executed, and that program job is to take the photo, remove all the background, identify and remove all the background, and then give you the fresh output where you will not see any background. That is what the traditional system works. Hadoop says we will not work on that way. Let the data sit wherever it is. I will not trouble the data as much as possible. Okay, let the code travel, right? So what I'm trying to tell you is, in this case, you have written a jar file, you have created a jar file, and when you submit that jar file, this jar file will go here. This jar file will go here. Your data will not move because you are not dealing with with kilobytes of data or megabytes of data. You are going to deal with gigabytes, terabytes, and petabytes of data. Is not it? So the data will not travel. The data would stay here as it is. It is the code which travels. Okay. Now, in your typically MapReduce program, there are mapper phase, there are reducer phase. So some sort of data would be emitted, when mapper phase is completed and reducer phase gets started, right? So you will understand this as you move on with our free course of 45 hours. Okay, so that's how the data would travel, and that's how the data would not travel in case of your mapper, right? And then the output of the mapper will have to travel to a place for aggregation for sure. Okay, but what I'm saying is Hadoop will make sure that the minimal data travel happens, and as a programmer, you will have to make sure that the data is not traveling a lot, right? For example, I'll give an example. Simple. See, if I say this B1 has a file like this, okay. Say this B1 has a file like this. Let's say 𝗀𝗏 5000 IT, okay, and let's say Kumar 7000 IT, and let's say Satish 12,000 IT. So in this case, suppose the requirement is to find out the highly paid employee in the whole organization, and you have similar data in this B2 file also, right? So in that case, I don't think there is any point to send these two data for comparison, right? Because I know that in this file I have this as a highest data. So you'll have to use some technique, some optimization techniques and all to make sure that the data sent across the network is minimal, right? So we will learn about that over the period of time. Anyways, so that's how Hadoop makes sure that the data is not traveling as much as possible. But I will not say that it is 100% true. Few data travels because the aggregation needs to be done on the data. Okay, so I hope you understood what exactly is this HDFS, what exactly is this MapReduce, and how do they really work. Okay, now let me talk about the Hadoop processes, right, that makes it possible to run your big data job. Okay, so see, when you are working with Hadoop 1, of course you will not be now, right? So you have component like name node, secondary name node, then you have job tracker, then you have task tracker, and then you have data node. Okay, and how do they look like? Let's see. The real cluster, whatever you could see, would look something like this. Okay, so if you look into this diagram, I have a 5-node cluster. I have a 5-node slave machines. Okay, and I have 3 masters. I'll call it masters. Okay, and I'll call them slaves. All of them are nodes and they are connected to a network. And this is a cluster 1. This is a cluster. Okay, this is basically a cluster. Now, in this cluster, the master node will have name node, secondary name node, and your job tracker. Okay, and your slave will have task tracker and data node. And these data nodes will basically create the HDFS for you. So HDFS is created out of this data node. Okay, so the data node maintains the HDFS, right? And this task tracker will manage all the work, whatever you are doing here. Right? Every machine will have their own task tracker, and that is the place where your data would be processed. Just give me a minute, guys. Okay. So yeah, so that's how it works, right? Now in Hadoop 2 and 3, your job tracker and task trackers are replaced. Okay, job tracker and task trackers are replaced, and now this job tracker is called as resource manager. Okay, and this task tracker is called as node manager. Okay, very simple to remember. This is a node, right? So each node will have a node manager. Okay, now this is basically will take care of the whole resource. So it is called as a resource manager. Okay, so you'll get to understand the whole architecture of Hadoop 2 and 3. How does it work? Hadoop 1, the whole architecture in the 45 hours of introductory program. Okay, so at a high level, this is what we have, and all the job whatever you schedule, that will be taken care by this job tracker or resource manager, and then they will be launched individually on these machines. Okay, your name node will keep name node will keep details of all the files whatever is stored across various data nodes. Okay, and this secondary name node will basically help to maintain the data, maintain the metadata file of name node, so that in case of any in case the name node goes down, then secondary name node can be used to get the information back whatever was stored in the name node. Okay, so you learn more about this in a detailed description of the 45 hours of training program. Okay, now let's talk about what is a ecosystem component, and this is very important for you to understand what exactly are the ecosystem components and how do they actually work together. Okay, now as I've told you, in the initial days, big data, when we say Hadoop, they had only two components, MapReduce and HDFS, right? And as you know that to write a MapReduce, one has to be very good at Java programming. And fortunately, not everybody is really good at Java programming. Right? Few people may be working in warehouse since last 10 years, 15 years. Now, all of a sudden, you cannot ask him to learn Java. Why will he even learn Java now? Right? Because he's about to retire in next 2-3 years, and it may not make sense for him to learn Java now. Right? So the problem was the problem with the Hadoop was MapReduce, and somebody has to learn Java to become a master in MapReduce, right? To solve the problems. So many companies, they started working on some alternative which will make our life easy, and you may not have to now write the same MapReduce program. Okay, and those programs later became the ecosystem of this Hadoop. Okay, so we have something like Hive, we have Scoop, we have HBase, we have 𝗚଼cie, right? We have so many stuff. We have Cassandra. Okay, we have Flink. We have many things, right? And later when like Hadoop gained a lot of popularity, people still saw that there was a drawback in Hadoop MapReduce framework, and they started coming up with a better solution, and which is now a Spark, right? So we'll talk about that also a bit, but right now let's try to understand about this particular ecosystem components. So as you know, MapReduce is basically a programming framework which is basically written in Java, which allows you to write a code that can run on a distributed machine, right? Your 2 lines of code can run on 300 node cluster. Okay, Hive is for people who are very good in SQL. Okay, and they say, hey, my data looks like a tabular format, and I want to do some analysis on the data, find out this and that all together, group by this and that, and I think I can get it done if the data would have been in a tabular format. Then they can use Hive, wherein they will write SQL query, literally SQL query, select star from employee, where employee salary is greater than 10,000, and group by this, and so on, right? So they will literally write the SQL query, but under the hood, it will be converted into MapReduce job. Okay, and this MapReduce job will be executed automatically. You don't, but at the end of the day, you are not writing a MapReduce job. You are solving the problem using SQL queries. Okay, next. Now we have a Scoop. Sometimes you may have a requirement that the data is present in RDBMS, and you would like to transfer that data from RDBMS to HDFS or vice versa. Okay, so in this case, you will use a component called scoop. So the requirement could be, I have a banking application where people are applying, like for a loan, or people are doing a transactions from many places, credit card or maybe debit card transactions or whatever, ATM machines transactions and all. And at the end of the day, all these transaction details are stored in my RDBMS, right? Because RDBMS is fast. Right? But now I want to bring that data together, and then I would like to do some analysis on that data. I have a lot of servers, and then let's say, people have written the data, whatever people have done, all the transactions, they're stored in various different servers. But at the end of the day, I would like to do some analysis on the last 3 months of data, right? So you may be interested to bring this whole data, which was stored in your RDBMS of last 3 years, into a HDFS, so that you can perform some analysis on it. So you would basically need Scoop to import the data and export the data to and from RDBMS to HDFS. Okay, HBase. So not every data can be represented in a form of table and rows. Sometimes you may have to work with unstructured data, wherein you have no clue how many columns would be there in a particular row. The first row may have 10 columns, the second row may have 300 columns, the fourth row may have 1 billion columns, and so on, right? So there is no guarantee of how many columns you will have in each particular row. So in that case, you can go ahead with Cassandra or HBase, which is basically a database system, right, which stores the data in HDFS, but they are columnar storage databases. Okay, so what the difference between Hive and HBase? Hive stores the data in a tabular format, whereas HBase can store the data as HBase basically stores the data as a byte array. Okay, so it can store any kind of data, and it does not really store the data in a tabular format. It basically stores the data. You can think of it as a JSON kind of format. Okay, wherein the first row can have a number of columns, the second row may have 10 columns, the third row may have 20 columns, and so on. So the columns are really not fixed. They work on the concept of column families and all. 𝗚ci is basically a framework, or you can say you also have something called Airflow. Okay, so 𝗚ci or Airflow, they are basically schedulers, and they can be used to automate a job. For example, let's say every day early morning at 6 o'clock, I want to run some code, and that code should pick up the data, process the data using MapReduce first, and once that is done, then it should load some data in Hive and then do some query on it, and the data should be exported back to Scoop. So what you're trying to do is you're trying to integrate your MapReduce, your Hive, your Scoop job, right? So the data is coming to you in HDFS. You do some processing using MapReduce program, and then you are doing something more with Hive, and then finally you are importing it exporting it back to your RDBMS using Scoop. So if you want to integrate, if you want to create this kind of connected components together, then you can use 𝗚ci or workflow. Okay, now Flink is for real-time processing. Okay, so this is how your ecosystem component can be. And there are so many ecosystem components. I would not say these are the only ecosystem components. There are so many ecosystem components which can be used to perform various other activities. Okay, it depends on the job requirement, which one would they prefer. Okay, now I would suggest you a best technique to identify what should you basically really prepare for your job. Okay, so I would suggest you what to do is go to LinkedIn or Naukri.com, okay, and try to search for big data jobs. Okay, try to search for big data jobs. Upload your resume in Naukri as well as search it in the LinkedIn, and try to see at least 20 requirements. Try to see the 20 job descriptions. Okay, and by looking at the job descriptions, you will start understanding the pattern. Like maybe everybody is asking Hive, right? And maybe everybody is asking you HBase or 𝗚ci. Okay, maybe a couple of people are asking for Scala Spark. Couple of people are asking for PySpark, right? And so on. So you'll start getting the pattern. Create a table. Create a table. Say, okay, I am seeing 4 job requirements is asking this. I'm seeing, let's say 20 job requirement is asking this, and I'm seeing 3 job requirements are 3 job descriptions are asking you for this requirement. And that's how you will be able to identify, okay? Because you should not trust any trainers. Trainer will try to sell their course, right? I have seen people saying that Java is not required. You should really not learn it, okay? Look into the requirement, because you cannot learn it as per your convenience. You cannot say, I like Python, I love Python for God knows reason, and I would like to learn only in a Python way. You have to understand how much demand it is, which one is preferred more, which kind of companies are preferring what, right? So based on that, you can move ahead. I have no problem if you learn PySpark as well, right? But look into the requirement, what is in more demand, which is more in demand, right? And try to take yourself in that direction. And that's the best way you can do, because you have to work, you have to learn as per the industry, not as per your easiness or not as per the trainer's easiness, right? So whatever you feel has more demand, can make your career more better, focus on learning those skills. Because learning this Java or Python or Scala, it itself will take 2 to 3 months, right? And how can you complete the whole big data in just 2 months? It is impossible, to be very honest, right? So you'll have to figure out what you should learn and pick up the best thing. Okay. Now let me tell you one surprising fact which you will also understand. See, Java was officially announced, I think, in 1995. Okay, late 95, early 95, and Python was introduced in 1990, late 89 or early 1990s. Okay, so what I'm trying to tell you is Python is still older than Java. Okay, now you have to understand one more point here. When 𝗥𝗘𝗘 wanted to implement the problem, the Hadoop solution, they chose Java, right? Python would have been much more easier for them, is not it? Think about it logically. Python would have been much more easier for them. If you feel that it is easy, like think about them, like they will find it much more easier, and they would have really implemented this very, very fast. But the question is, why did they still choose Java? Because of only one thing: robustness. One thing is guaranteed, that this will never break. Okay, today you install Java in your computer, it says 4 billion devices are using Java, are running on Java, right? You install Python, there is no clue about it, right? So I'm trying to convince you, why should you learn Java? Because the whole world is running on Java, and if you have not done it, this is the right time. Nothing is late, right? So if you have not done it, do it now. If you do it now, after 3 years, you will find yourself very comfortable in Java. Or else you'll still cry saying that, hey, Java is hard, right? And it is hard unless and until you don't start. If you start, today it is hard, tomorrow it is a piece of cake. For me, I have been doing, I'll tell you, like I'm from ICSE board, wherein we used to have C++ programming in class 9. Right, and I was introduced to programming languages in class 9 when I was hardly 14 years, right? Now today I am 32, right? So I have almost done 18 years, right? So 18 years of programming. And that has really helped me a lot. Okay, of course, I was not an expert or pro when I was just learning those C++ syntax in class 9. I was hardly able to understand what is a prime number, how do I write a logic of prime number, and all that was completely out of my mind. But over the period of time, whatever I've spent those days, right? So they have started giving me a good base, because it's been 18 years doing some sort of programming here and there every day, right? Okay. So I hope this is enough for you to, understand that Java is what you should basically learn, because the whole world is using Java. Every device is running on Java. And now the question is, when people, when this Spark was invented, Spark was written in Scala, and Scala is another JVM language. Now my question is, why not Python, right? So if you cannot convince me that a Python would be much more better, because it's not just about writing easy code, it's about writing a code that will run forever. Okay, you talk about any banks, a good banks, look into the backend main logic system. You'll find them written, they are all written in Java. I have worked with a company called Discover. It is a kind of Visa and MasterCard in US. We use Java system. We had close to 1,500 employees working on various projects, and most of them were working on Java, right? So that is the importance of Java. If you don't understand it today, tomorrow may be very, very late. So start learning it now, so that if you start now, at the end of 2 months, 3 months, 4 months, at least you'll start feeling it easy, right? If you say it is difficult, it will be difficult forever, right? I took this as a challenge, learning C++ programming. And trust me, I was one of the very poor student in the class, because it was not like I was not able to solve the problem, right? But I took it as a challenge. Okay, I thought, okay, let me take some time, because it is taking. Somehow I managed to get the pass mark in the board exam. Otherwise, I have my very, very good friends who even scored 11 out of 100. Trust me. And if you know, then ICCA board allows you to get a fail mark in one subject out of so many, and that's the reason those people still manage to come out of this the 10th. Otherwise they would have been detained for a year, right? So that's how it is. You start early, and then you'll be definitely able to finish it really early. Okay, so we have talked about this. Now let's talk about what? Let's talk about distributions. Okay, let's talk about Hadoop distributions. Okay, so see, Hadoop is a product of Apache Software Foundation, right? Many people like us, many people basically they build some tool, and if they feel the tool is really good, they contribute it to ASF, Apache Software Foundation. And this is a company who basically manages a lot of projects. Okay, and these projects are all open source. Means source code is free, and they are free forever. Okay. However, there are companies like Cloudera. Okay, you have Databricks, Horton, which are now merged. You have MapR, okay, and many other companies. So what they have done is they have taken the core Apache Hadoop, Apache Spark, all the Apache product. They hired a lot of engineers, okay, and they started grooming it. They started grooming this product. They started making more better this product. They started customizing this product, and then they started selling it to the customers with support. Okay, what is the difference between Apache Hadoop and Cloudera Hadoop? The only difference is they have fixed a lot of bugs which otherwise are not fixed in the main component. They have come up with their own UI and all, which can make your life much more easy. And whenever company uses Cloudera Hadoop, and if there are any bugs in the middle of the night, it is the headache of the Cloudera to resolve it at the earliest. You don't get a support with the open source because you are not paying anything to them, right? And they say we cannot guarantee you a support, right? And that is the reason a lot of companies are actually going with one another distributions. Which one is best, which one is not best, that depends, right? For example, see, more or less from a developer point of view, everything is equal for me, because I really don't care what kind of distribution I'm using. The program to write the word count would still remain same. Is not it? The way they are optimized at the architecture level, at the cluster level, would make a difference. Otherwise, from a programmer point of view, it will really not make a difference. So if you want to go ahead with the certification, you can go ahead with Databricks, you can go ahead with Cloudera, you can go ahead with MapR. Anything is fine. Okay, anything is fine, and you can definitely use any of them for your certification. Okay, so guys, that's all I have, and I hope you have enjoyed this session. Now I'll quickly show you how can you get access to the 45 hours of free course. These courses are free today. This course may not be available tomorrow, I don't know. So I would like you guys to take this up as soon as you can, so that you can utilize it. Okay. So I will promise you that I'll conduct one more session, maybe on a project wherein we will see a real-time Kafka with Spark and Scala. But before that, I want you guys to finish my 45 hours of course, so that it can help you better. Okay. So now let me just share my screen. I'll quickly share my screen, and let me take you to my website. So are you able to see my screen, guys? Yes, everyone? You can just ping me in the chat. Okay, so so this is the website name. So you just go to onlinelearningcenter.in and click on this join 45 hours of free course. Click on it, and you will be taken to the next page. Click on it. You will be asked to register with your LinkedIn profile, Facebook profile, or Google, whatever platform you want to. And then you'll get access to this course. Start learning this 45 hours of course. Okay, because I'm sure that is going to change your thinking in terms of big data for sure. Okay, now as I have told you, we have a complete program, 10 months of exclusive course as well. If you want to take that, you can also reach out to me personally, and I can help you getting into it. Okay, so this would be completely the most exclusive training program whatever you see in big data. And I'm sure that you will not find any training center giving you a 45 to 48 hours of free course, because if they do so, then you will realize that they just teach you the basics, right? And we have an exclusive course of 230 hours, because what I felt is the 8 years of experience, whatever I've spent in various different companies, working with various customers and clients. And I saw that it is not possible for me to wrap it up in just 2 months. And that's the reason 45, 50 is equivalent to 2 months of course. That's the reason I'm giving you a 2 months of course for free to help you get started with the course, right? So once you start with this program, then you can take it forward on your own. You really don't have to come back to me for the course. If you feel you can learn it everything on your own, you can definitely go ahead and learn everything on your own. Okay, so if you, I would suggest you to spend some time with this website, because we have come up with a very beautiful concept called interview questions, wherein you can, contribute. You can contribute interview questions, and you can be a part of it. So I'm very proud to say that we have collected almost 172 plus interview questions from 172 companies on 42 different topics, and there are 135 people like you who have contributed their part. So this interview question section is accessible only to this 135 people, and I have promised them that I will never ever make it public. I'll never ever make it a monetary course, right? So this would remain free, but it will be always for our contributors. So in case you have learned Hadoop from XYZ Training Center, it does not matter. Okay, you have gone to the interview, you are not able to crack the interview, you failed in interview 1, 2, 3, come back to me. Contribute your part of all the interview questions, whatever you have attended, and you will become a member of it, and you can easily get access to all these interview questions. Okay. Similarly, we have come up with the job updates. Sometime I get, call from small companies who says, we are looking for big data developers. Can you provide me one? Okay. So we have created a job updates section, wherein you can upload your profile, and your profile would be sent to the recruiter. The recruiter will look into your profile, and they will contact you if your profile looks really better. Okay. So we have also started this program, and this is also free. Okay, this is absolutely free. All you need to do is upload your profile in our OLC website, upload everything whatever we need, and we will make sure that that reaches out to the the recruiter, whoever are looking for the candidates, right? It will not cost you anything at all, right? So this is what we have built a platform. We're going to build the best ever platform in big data, because I feel that it should not be just a course, right? It should be a complete end-to-end, because when you are taking a course from anybody, you would expect them to support you at the end of the course. We have a lot of success stories. We have a lot of people who have actually taken our course, the full course. And if you want to see that, let me share my screen again. Okay, so if I go back here, if I go back to my home, if you see, we have 238 Facebook reviews. The reason why we chose Facebook review is in Google review, you cannot even contact a guy and you have no clue whether that guy is a real student or not. But what we have done is we have managed everything in Facebook because you can see the guy's profile. Is he a fake guy? Is he, like you can see if he has only 4 friends possible, right? So you can just go through the reviews and everybody has written their beautiful reviews, and I'm sure anybody spending money, and if I don't provide them a value added service, then I will never get a single good reviews at all. So 248 reviews is not a joke, right? The number itself speaks a lot. And let me tell you that we have a success stories where we have kept it over here, wherein I have just managed to get some of them here because this platform is built very recently. So you can see we have our students who are getting a good package like 20 LPA, 6 LPA, 10.2, 18, 15.5, 22 LPA, 17.5, 8.5, and so on. So the salary depends on your current designation. Salary depends on your current pay scale and how good you have given the interview. Don't believe on the rumors, because many people will try to sell their codes saying that my student has got 700% hike, 1000% hike, 500% hike, 8 times better. That does not happen over the period of time. And I believed that I should basically talk with proof, right? We have, and that's the reason what I did is I took the screenshot whenever student says, hey Suraj, I got an offer from this and that company. We have not highlighted the student's name, and we will not do that because all of them put experience of 3 years and they don't want me to reveal their name, right? And that's the reason we will never tell you the name of that student. But all the students are in our separate WhatsApp group, and if you are our paid member, then you will be, once you complete the course, you will be a part of that group where these guys will help you, will guide you, and will also try to refer you for the course, right? So look into this, and then I'm sure if we are building a lot of things, we will not announce anything before we are done with that. But yes, you can go to this exam dumps as well, wherein you can give some test and see how good you stand in the subject. Now this is not a simple program like what is the difference between Hadoop and this and that, right? So we have collected the real certification exams. So this is what we have for you guys, wherein you can just go and give some exam and see where do you really stand in terms of big data, right? And for our premium members, we have more and more exams because we want them to succeed much more better, right? And we have also a hackathon system wherein we created a webinar, we created a test wherein you can just go and solve the problem. And these are some of the problems which I ask you in the interview. So whenever I take interview at my work, I will never ask you what is the difference between data frame and data set, okay? Or what is the difference between MapReduce and Spark, or what is the difference between this and that? Because I personally believe that I should not ask you something which you can even easily Google it and which does not make any sense. In fact, what I do is I ask you to solve a big data problem. I'll give you an assignment, right? And you have to solve that problem in an hour, right? And I say you can use Google, you can Google it out, you can learn YouTube videos, you can study from YouTube videos, whatever it is. But at the end of 1 hour, I want you to give me an answer which works, right? So those kind of questions, some of the questions which I basically keep asking you, they are present in this big data hackathon. And we have a big data hackathon for in 2 shapes, public and premium. These premium hackathons are exclusively for our students because we want them to practice more and more, right? So only premium students will be able to access this hackathon, and we conduct this hackathon live to our students so that they can solve more problem on demand, right? We don't even give them 5 days to solve this problem. We say, if you have a hackathon, you have to solve it in 2 hours, and people will be solving this, making their career more ahead. Okay, so that's what we have an offering, guys. So it's up to you whether you want to just take our 45 hours of course. I've seen many people taking the 45 hours of course, they learn it for 4-5 hours and they are done, right? So you have to motivate yourself. Nobody would do it for you. Why would I motivate you? I will not motivate you. I want to motivate myself only, right? So at the end of the day, it is you who have to motivate yourself. So if we have given you a 45 hours of course, I want you to try hard to complete this 45 hours of course. My system is much more intelligent and it will understand who are the people who have completed 45 hours of course. And as I promised you that once you finish this 45 hours of course, I will schedule a live session on a project wherein we will see Kafka and your Spark and Scala working together with the Tableau. Okay, and we will try to do a COVID-19 analysis, to see the various stats on their dashboard, and we will do that in front of you live, exactly live. Okay, so that's what we will do. But yeah, I cannot give you the dates because that date depends on how fast you are finishing the course. You finish the course, I will be informed by my platform that these many people have completed the course. The moment I see there are 50 students who have completed the course, I will schedule a batch, and we will have a real-time discussion. When? That totally depends on you now, not to me. Okay, all right guys, so that's all I have. You have any questions for me?